All right, this is the practice test review for the quiz on thermochemistry. First, multiple choice. When a system does what, the change in energy is always negative. Change in energy, we can also write that as Q. So, absorbs heat and does work. Well, if it absorbs heat, then the energy might not be negative. When it does work, so doing work gives up energy, absorbing heat takes in energy. So you might end up with a positive value for E or Q. But if you're giving off heat and doing work, both of those require you to lose energy. So no matter what, no matter how much of each one you're doing, you're always going to be losing energy. When you're absorbing heat and having work done to you, that's going to be always positive. And none of the above is not an option. Which one of the following is exothermic? Okay, exothermic, again, remember, means negative Q, or it means you've got a system that is losing energy. The system is our point of view. So from our point of view, which one of these means we're losing energy? Ice melting? No. If you're the ice and you're melting, that means you're absorbing energy. Water evaporating, which you could think of that as like boiling, also means you have to absorb energy in order to do that. Boiling soup. Anything you're boiling, you're putting energy in to make it boil. The only one of these that is exothermic is condensation. So in order for water to condense, it has to cool down. So that means you're losing energy to the surroundings. So that's an exothermic process. Which one of these is the law of conservation of energy? All of these have to do with energy, and these are all true, but the only one that really summarizes the law of conservation of energy is that the energy lost by the system must be gained by the surroundings. In other words, the energy just moves from one to the other without being destroyed. So lost by the system doesn't mean lost forever. It means it's lost by the system and given to the surroundings. So the energy is still there. It's just moved from one place to another. What type of value for Q is what type of process? So we need a combination where it makes the whole statement true. Well, negative Q is not endothermic. Negative Q is exothermic. Positive is endothermic, and 0 is neither. So negative for Q equals an exothermic process. Okay, a reaction that absorbs heat, so heat going into the system, is what? Well, heat going into the system, first of all, is endothermic, so we can right away rule out those two. And has what kind of value? Well, if you're adding heat, absorbing heat, that means Q is going to be positive. So that's the correct answer there. Endothermic process has a positive value for Q. All right, let's take a look at some of these specific heat problems. We have a 5-gram sample. We want to know, the question is how much energy, so we're solving for Q. We're given the change in temperature from 20 to 80. We're given the mass, and then we're given the specific heat. If specific heat equals the energy divided by the mass times the change in temperature, then the energy equals the specific heat times the mass times the change in temperature. And we're given the specific heat is 0.092, the mass is 5 grams, and the change in temperature is 80 minus 20, or 60 degrees Celsius. Okay, when you multiply that together, the change in energy, this is in calories, because this was given to us in calories for specific heat, is 27.6 calories. Okay, that's how much energy is absorbed as this copper heats. Okay, it's positive because the temperature goes up. How much heat is absorbed by a 20-gram boulder? Okay, so 20 grams doesn't sound like much of a boulder, but anyway, again, we're trying to find how much heat. So we're trying to find Q again. So Q equals the specific heat, which is 0.1, times the mass, which is 20, times the change in temperature, which is from 10 to 29, or 19 degrees. When you multiply those together, 0.1 times 0.9, times 19 times 20, you end up with 38 calories. Again, calories because we were given the specific heat in calories. How much heat is released? So again, this is another, try to find the Q. Q equals the specific heat, given 1, times the mass, which is 30, times the temperature change, which is 96 minus 25, or 71 degrees Celsius, So that means the Q equals 2,130 calories. If we need to find, in this case, what is the specific heat. So this time we're trying to find C. C equals heat over mass times temperature change. So in this case, the temperature change, or sorry, the heat is 10 calories. The mass is 3.1 grams. And the temperature change is 17.9 degrees, because it says the temperature rises, so that's actually giving you the temperature change right there. So when you do that math out, you end up with a specific heat of 0.018 calories per joule per gram per degree Celsius. Okay, it's in calories, so our answer has to be in calories. Okay, last one of these. The temperature of a sample of water goes from, here's the temperature change, we're given the Q of 5650 and the specific heat. So this time we're actually trying to find the mass. That's what we don't know. So if the specific heat equals the mass times the temperature change with the heat, then if I rearrange the equation, I get the mass equals the heat. So it's the heat divided by the specific heat times the change in temperature. So let's plug in what we know. We know the heat is 5650 calories. We know that the specific heat is 1. And the temperature change is 20 to 46.6, which is 26.6 degrees Celsius. When we calculate that, we find that the mass of water that was heated is 202.4 grams.